Software Architecture with Rockford Lhotka.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back. I'm your host, Jeffrey Palermo, and make sure to go to www.azuredevops.show for past episodes and show notes. Our guest today is Rockford Lhotka. Rocky is the CTO of Magenic, an open source software architect, a professional author and speaker, Microsoft regional director, and avid outdoorsman. And Rocky and I just ran into each other again at the MVP Summit a few weeks back and plotted this interview. Rocky, how are you doing, sir?
I'm doing great. I'm glad to be here.
Awesome. So I hear the snow is melting in Minnesota?
Yeah, we had no snow. Life was good. Then we got dumped on with a late April blizzard, and so now by the end of this week, hopefully we'll be back to spring again.
Awesome. I see you're wearing. I can see through my video channel. You're wearing, I think, a hoodie, and I think I own one of those in Texas, but I'm not sure where it is.
Well, it was a Build 2016 hoodie that came out Infragistics. It was from an Infragistics party, I think, at Build in 2016.
Awesome.
Super comfy.
So for those who might not be familiar with you, and there might be 2.5 people out there, because you've been mover and a shaker in this industry for a long time, but why don't you give us a rundown of how you've come to this point and what your journey's been?
Yeah, well, I have been in the industry for a long time, and luckily I continue to enjoy it. I think we're, at least a lot of us that are in this industry are in a position where our work and our primary hobby probably are the same thing. So it's kind of cool. But yeah, I got started back in the late 80s, actually, and building software on DEC-VAX computers. And then when Windows came out, especially Windows NT in particular, jumped onto the Windows bandwagon. Visual Basic at the time was kind of the ascending productivity tech. And so I got involved with that. I was kind of known as a VB person for a long time, up until .NET, and we've been riding the .NET bandwagon ever since.
And you have, for those not aware, you have a popular open source library called CSLA, and that's on .NET Core now, right?
It is, yeah. And that actually started. The first version of that came out in 1996 or 97, somewhere right in that time frame. And of course, it was all COM at that time, and rewrote it for .NET, and then for Silverlight, and for Mono, and all of the flavors of .NET. And so now, it runs on .NET Core, .NET Standard. Right now, we're busy working on making it sing and be happy with .NET Core 3. So,
yes, which just a few more months to go, or so is rumored.
That's what. We'll see.
So,
they said, what did they originally say? Something about early 2019. And when I heard that, and then they were, of course,
they dropped the early,
saying, and we're going to do Windows Forms and WPF. And I'm thinking, oh boy, yeah.
Right.
I think maybe they underestimated the amount of effort to get those to really work in a whole new platform.
Right. But that actually is pretty exciting, because the native Windows desktop tooling just kind of got ignored for a while. I mean, I'm sure you've done significant WinForms and WPF, and then, okay, today, if we were going to do a desktop application today and we want to use the latest and greatest, I guess it's WPF on full framework, because .NET core Xamarin, but then it's just not quite cohesive just yet.
Well, you're missing out UWP because everybody flocked to that.
Yeah,
Not so much. But I mean, theoretically, that would be the latest and greatest, Windows tech is the UWP. But the reality is that so many people built so much stuff, especially on Windows Forms, and a lot of people jumped on WPF when it came out for good reason because the XAML, is pretty darn nice.
Right.
I think Windows 8 is really, the intro of what we now call UWP with, WinRT at the time. But that was really suffered a lot, I think, because Silverlight and the kind of abrupt drop of Silverlight on Microsoft's part left a bad taste in a lot of people's mouth, a lot of fear that maybe Microsoft wasn't sure where they were going. And so nobody really wanted to jump on WinRT. And then UWP only runs on Windows 10. So you're still left in this spot where, well, if I want to run on the vast majority of Windows desktops, WPF remains the best choice.
Right.
And now I think we really have a nice reinforcement of that, though. If WPF is going to run on .NET Core 3, I think I suspect a lot of people breathed a big sigh of relief at this point and said, "Oh, good! Now I can just keep doing what works. What's solving my business problem, and it's going to carry forward, probably for a long time into the future."
Right. So speaking of client-side technologies, let's talk about the client-side transformation that's going on, not just in native, but I mean in the web world, because so many things are changing. Where do you think it's going to go?
Well, that is the huge question, and I certainly have my hopes, my what I think might happen and what I hope might happen, what I fear might happen. And to kind of set the stage, at least for my thought process, really goes to the introduction of the iPad. Because prior to the iPad showing up, it was pretty safe to develop for Windows desktops. You just pop out WPF or Windows Forms app and be pretty happy. And then the iPad, the media, there was a lot that went on all in that short time frame, the post-PC era and all these other things. And all of a sudden, it was having an app that runs on Windows was no longer good enough because your CEO probably bought a $600 iPad and came to the IT group and said, "Well, why can't I see my stuff?"
Yeah.
And the IT group is like, "Well, we'll have to rewrite it in a whole new tech." And the CEO goes, "Well, that's good because I want it to work on my iPad." And objectively, this was really dumb because we've got probably trillions of dollars of software that was built or rebuilt so that the CEO could see it on their iPad. A $600 device driving multi-million or billion-dollar software decisions. But
there's also tons of web applications that were almost hard-coded to IE6 as well.
And, there are still organizations out there running Windows XP because of that, right? So that, in a sense, it's all water under the bridge. What it did was it drove most enterprises to write most software to target browsers that could run on iOS and any other platform, which generally ends up meaning Chrome and Safari or WebKit, right? So that's where we are today, 10 years or give or take, 10 years later. I had hopes over the last number of years that folks would go, but we could be writing native apps. We could be using Xamarin Forms or some other technology. And instead of writing for the browser, we could write native apps for Windows, iOS, and Android. But I think that has never panned out primarily because the web deployment model I mean, that's always been the Achilles heel of any smart client tech is deployment. And neither Apple nor Google helped in this regard, and nor did Microsoft for that matter, when they came along later. With the whole store model and the idea of enterprise software deployment is kind of a second class citizen. Nobody really gave it a lot of thought. And, enterprises don't want to run through the Apple store. They just want to deploy their stuff to their employees.
Right.
You know what I mean? So the browser is really compelling. And so then we get to today where I have a lot of potential excitement because of this thing called WebAssembly. The drawback to the browser is that the only language supported in the browser is JavaScript. And some people, of course, are hearing that and they're like, wow, but JavaScript is the best thing that mankind ever has or will create. And it's the pinnacle of all of our innovation. I think a lot of us look at it and go, well, if you read JavaScript, the good parts, and restrict your usage to that small book and ignore the rest of the crap that's out there, it's not bad. But really, it stifles innovation if we can't build other languages or do other cool stuff.
We have to question why Google, who created Angular, ditched JavaScript for TypeScript.
Yeah,
I mean, because they're pretty smart guys and gals.
Well, TypeScript, I chuckle sometimes because, of course, being a Visual Basic person throughout the 90s, I got a lot of crap because VB for the longest time was a typeless language. And eventually we got options strict and we could turn on types. But JavaScript, for some reason, glorifies in having no types. It's like the reason I love JavaScript is because it doesn't have types, and yet I suspect many of those same people are the ones that were hating on VB back in the 90s, right? So it's like it puzzles the hell out of me. So
I think they were in kindergarten.
Yeah, that could be true. That could be
whole other generation. But yeah, it doesn't have any type. It doesn't have the type, so it has just natively less tooling available for it.
Right. Yep. So, I think TypeScript is awesome and helps a lot. But WebAssembly, and boy, there's a lot of misunderstanding out there about what WebAssembly is today. So, WebAssembly is a compiled runtime that's at the same level in your browser as the JavaScript interpreter. So they're peer level constructs, and because I keep reading things, people are like, oh, well, WebAssembly is just JavaScript, which it was back when it was asm.js a few years ago, but that was a prototype.
Yeah.
What it is now is a real live, honest to God compiled engine that's sitting in the browser at a peer level with JavaScript, except that it downloads assembly language and then JIT compiles it for your platform.
Yeah.
And so, and what it allows then is for C, C++, Rust, C#, various languages to compile to that assembly language, download those binaries, and run them in the browser, ultimately at native or near native speeds. It's damned impressive.
I think it's kind of interesting that the browser, which would normally just say, hey, web server, give me a bunch of text and I'll figure out what to do with it. Instead, it's saying, hey, give me the URL so that I can on demand, just in time load the application.
Yeah. Well, really, you think about it, the browser effectively becomes our new, you can use the word runtime, but I think of it as essentially it's the new operating system.
Mm-hmm.
Right? If I'm a client-side developer, and today this might be a little bit of a stretch, but in another 2-3 years, as the WebAssembly and the tooling and languages mature, why would you write for iOS or Android or Windows or Mac or Linux? Because you can just write for WebAssembly and it
run everywhere.
Actually really does run everywhere, because you don't care about the underlying OS. That's just a platform to run the browser.
Right.
Which is really the same mentality as the Angular TypeScript folks. but now we're going to be able to do it with near native speed.
And then any device that can run a browser that can run WebAssembly becomes essentially able to run your application.
Yeah, exactly right.
That's pretty exciting. And then the only thing we have to, we've always had to think about screen size, so that doesn't go away.
Nope.
But we're not having to think about does it support this API or that API? Not to some extent, but there's plenty of common surface area for tons of business applications.
Right. There are always different classes of app, right? And so, I come at it from primarily a business application perspective, because that's what my career is, building, business apps. And so people might come along and go, oh yeah, but I build, device, low level system control apps or utilities for the Mac or all sorts of stuff. And yeah, it's probably true then that WebAssembly is not for you.
Those guys are used to choosing their own microcontroller.
Yeah. And that's great, right? But then you do wonder, will there end up being a bunch of equivalent system level utilities for browsers? If the browser really is the new operating system, then do we need like the Windows sysinternals? Do we need a bunch of sysinternals tools for browsers? I don't know. It's weird speculation.
We'll need enough debugging tools, that's for sure.
I suppose people are going to say, well, no, F12 is enough. And maybe that's true, right? I don't know.
Right. So the current stack, and you and I have both been on the Microsoft platform, or generally our whole careers, and kind of gone with the flow of that. And so there's just tons and tons of companies out there, and their teams, they would just identify themselves as, hey, we're .NET shops. And their core skill set is C#, and they put their data primarily in SQL Server. And now they've been asked to have these SPA front ends. And so they've been asked to learn JavaScript or learn TypeScript. And so what would you recommend they do today? I mean, we've said, hey, keep an eye on WebAssembly. What would you recommend they do today in mid-April 2019 if they're a .NET shop?
If they are a .NET shop that's currently using WPF and all that stuff, maybe continue to do that. I think you've really got kind of three big picture options, right? One is to continue down the Windows client road, if that's where you are. Or you got to pick a SPA framework like Angular or React and go down that road, and all of what I would describe as pain and suffering that comes with it, because so much of the things that you're used to just don't exist, or if they exist in such a radically different format that it's a huge learning curve. And this is all an appetite for risk, really, right? But you might start seriously looking at Blazor, which is the WebAssembly. It's a Razor syntax. So again, you're back in the web world, kind of, but you're writing smart client. It's a UI framework that Microsoft has created for WebAssembly. And this may be a little more experimental even yet, there's some other open source implementations for .NET developers, including the Uno platform, which is UWP XAML that runs in WebAssembly. That one's pretty cool, fairly mature. There's a fairly immature effort out there to create a Windows Forms runtime in the browser using WebAssembly. So, and then there's Wii, which is another one that uses Xamarin Forms XAML to run in WebAssembly. But really, I suspect that what most people are going to do is look at Blazor because it comes from Microsoft, and so there's the kind of stamp of authority, that comes with that. But
it is pretty compelling. I mean, if the first edition of that comes out with .NET 3, and the promise is to be able to write C# all the way through your application, that could be pretty compelling if that's the core skill set of the team.
Well, I think so. We talked a little bit about CSLA earlier. I have CSLA running in WebAssembly now, and so You really can build a Blazor front end app, smart client app, using C# and HTML in that case, and use all of and I bring out CSLA just because it uses a lot of .NET, and so the fact that you have access to basically all of .NET running in the browser on the client, and then you're able to make server calls back, create an N-tier app, talk to your app server /web server to talk to and then it talks to your database, and the stuff is all very realistic today. But I do come back to appetite for risk, right? In that it's also very, very, very new. And most of it is in a pre-release state. And so, that's where I guess if I'm a .NET developer that is currently a Windows client developer, I'm going to stall for time.
Mm-hmm.
Right. If I were in that spot, I'd say, let's keep doing what we're doing for another couple of years, because this WebAssembly thing might give us a road forward. And if you can't stall for time, then really you have no choice but to retool and become a server-side developer, or go out and learn Angular or React or something.
Mm-hmm. Yeah. Well, with so much going on the front end, there's also, this seems to be a server-side transformation going on with how code runs just on whatever server is chosen. There's cloud transformations. There's talk about platform as a service versus containers, and so much going on there. What are you paying attention to at the moment?
I'm really watching and deeply interacting with Kubernetes and the container. It's a container orchestration engine for Docker containers, although even the term Docker container seems to be fading to just be container at this point. And I honestly think that, I think it'll be Kubernetes, but it could be something else. It's still young enough that we don't know, but I'm quite confident at this point that the container, the Docker container type model is where the industry is settling. And I think about it that if you're targeting a PaaS-based scenario, platform as a service, so you're saying like Azure App Service or AWS EC2 or something like that, the way I think about it is you're still actually targeting a container, in that Microsoft on Azure created a runtime environment and says, hey, you can run any code you want as long as it conforms to our container rules. In other words, we've picked the version of Windows, we've picked the version of ASP.NET, we've picked the version of Python, or whatever. And so if you can conform to our choices, you can run inside of our app service, and away you go, which is pretty darn awesome, right? Highly productive. On the other end of the spectrum, you can say, well, but I don't like all, I want control. I want all the control. And then you run in a virtual machine, but then you literally have all the control. Your IT staff have to manage the virtual machine, patch the operating system, patch the runtimes. I mean, it's no different than running a normal machine, really. And so, to my mind, containers sit in this really nice spot in the middle where the most of the runtime is taken care of and abstracted away from, where you don't have to worry about it. But you still get to pick the version of Node that you're running, or the version of .NET that you're installing, or the version of Python, or right. You have just enough control, but not too much control. And it just seems like it seems like it hits the sweet spot.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So it seems that there's this continuum of control versus control that goes along with responsibility and level of maintenance And of course, on the one side is you're running the stuff in your own data center, and you even have to screw the servers into the rack. That level of responsibility, maintenance, and control. To the other end of the spectrum, where you say, "Hey, I have some .NET code. Azure, can you run this, please?" Mm-hmm. And so on the progression, where VMs kind of somewhere in the middle, but where do you see containers versus PaaS and Azure Functions fitting in? Because for those people that just say, "Look, I just want the no drama, just run my code, please."
Yeah, I think were I to list the spectrum, I think you hit it on the head, right? Where you're building your own racks and installing your own hardware. That's certainly on the I have complete control level.
Yeah.
And then from there, you run up to virtual machines. And from the next abstraction on that, I think, is containers, like Docker type containers. And then PaaS, and then function as a service is probably the where literally you are saying not just I have code, but I have a function. Hey, Azure, please run my function when these events occur. And then there you've given up as much control as we have figured out how to give up at this point.
So there seems to be mixed messages around which one is more forward-looking, container or PaaS. And if someone just says, "Okay, I don't really understand about either one. I'm just modernizing, and I want to use the latest and greatest," which one should I be really investing in?
Yeah, and that is a good question. And I think it really comes back to that risk profile concept that I mentioned earlier, because I think we're a good 10 years into platform as a service, especially on Azure, and close to that on AWS. And so we're at a point where the platform as a service ideas are pretty stable, well understood, and they've become quite mature, which means that their risk profile is pretty low. And they're pretty forward looking, especially if you're not yet in the cloud. All of this stuff is pretty forward looking. And so I don't think anybody should look at PaaS and say that it's a bad idea, because it's not. It hits a really sweet spot. If your risk tolerance is a little bit higher and you want to, I think, be even more forward looking, then you say, well, how do I get into containers? And that's kind of a spectrum, though, because there's both Azure and AWS and Google all have the ability to run containers in their platform as a service. So if you take Azure, for example, the app service, you can just upload some .NET, ASP.NET code and run it. And that's kind of what we think of as PaaS. But it turns out that today you can also upload a container and app service can run that. And so that's like the next step in a sense, maybe. And then if you want to go all the way into the container world today, that probably means going into Kubernetes or Kubernetes, however, I have never figured that out. So then you go and Azure has Azure Kubernetes service, and there's AKS on Azure and EKS on AWS, and PKS on Pivotal Cloud Foundry has got Kubernetes that runs in it. So basically, almost everybody at this point has a Kubernetes offering, and that gives you like the native container orchestration engine that everybody seems to be settling on.
It's interesting, the convergence of containers and PaaS, whereas you could provision and host your own container cluster, or Kubernetes cluster, or you can just package your application in a container and say, hey, Azure, run this in your Azure Container Service, which is part of app services. And so then the question is, okay, if we're going to try to fast forward ourselves 10 years into the future, is a Linux format container going to become the de facto standard .NET Core package format?
Well, I think so. I absolutely, that's where it's going extremely rapidly. At least in my observation, the customers that we're working with, basically, as everybody's going into containers, they're either using Windows containers in order to lift and shift existing apps that are still running on the .NET framework. And we see a lot of that in Pivotal Cloud Foundry, because their ability to run Windows containers is pretty mature and has been around now for a couple of years. And Kubernetes, like literally just the version 1.14 finally got support for Windows containers. And so that we have yet to see that happen, but I suspect it'll be the same thing there, where people are running Windows containers essentially because they want to run in some legacy website that they don't want to rewrite into .NET Core. But all the .NET Core work that we've been doing over the last couple of years that runs in containers has been targeted at Linux containers.
Yeah, isn't that peculiar how the whole Windows .NET ecosystem is just almost like, without even having an intense discussion in the industry, is, well, Linux is supported better, so yeah, we'll just run it there.
Yeah.
Well, there's so much. You mentioned sysinternals. I mean, there's so much debugging and tooling and industry knowledge around how this stuff runs in Windows, and when it goes wrong, how to figure out what's happening.
Yeah, but those equivalents exist on the Linux side too. Yep. Just that Windows administrators aren't as familiar,
right?
But I think we're at an interesting point where the app dev world is quite far ahead of the sysadmin world at the moment. I could be wrong, and maybe it's my app dev perspective, but I say this because an awful lot of our customers, as we're going in, are asking us how to set up and run all of the container-based infrastructure, because their sysadmins don't yet know how to do that stuff. And we're looking at Linux for two reasons. One, like you said, it's from a container perspective, it's much, much older and more stable, whereas the Windows container stuff is pretty new and I would say untested, right, in the real world. And then the other thing is that in a lot of cases, Linux is cheaper to run. Right, licensing costs and there's a variety of factors. And as a developer, and this is something that I really kind of crystallized in my mind only in the last 6 months or so. If you really buy into, especially a microservices based architecture, and start building your server side code as a set of services, using .NET, or for that matter, Java Spring too, it's the same thing, really. You don't care about the underlying operating system. You're writing a bunch of code that is responding to some sort of an inbound message, essentially an event. You're running some algorithmic code and giving back a result, or you're talking to a database and giving back a result, or you're talking to other services and you're right. Essentially, at no point do you talk to the underlying operating system. So you don't care. Really, you don't care if it's Windows or if it's Linux. Whoop-de-doo, right? And so then it becomes literally a matter of which one's cheapest, which one's the most stable, which one's the easiest to manage. And the answer today for all of those, at least in the container world, ends up being Linux.
And if you're right about what you mentioned on WebAssembly, that you just don't care what device because you're in the runtime, then that would correlate to the server-side world as well, that, hey, if it runs in the chosen runtime and that runtime happens to run somewhere, then my app will run, it'll run there.
See, and now you're this is the center of my excitement about the future, is that exact what you just said, in that if I can write a .NET client that runs on any client device anywhere, thanks to WebAssembly, and I can write .NET server-side code that can run on any server anywhere thanks to containers. I'm like in .NET heaven, right?
That's pretty compelling. And so, with this changing world, people are having lots more conversations about breaking up their software systems and not creating new, really large monoliths, but thinking, hey, how many pieces need to be a part of this system? And then they start talking about this word microservice and say, we'll use a microservices architecture. And so many people are asking, hey, what microservice, architecture are you using? And then they're searching for these templates out there so that they can point and just say, I do it like that. And, the industry is kind of lacking lots of good examples where the people promoting microservices agree, what is a microservice? So what say you?
Nice summary of the problem. That was well said. And it's true. It's there are so many, the term microservice means so many different things to so many different people. I've actually written some blog posts, one in particular, the micro part of microservice is horrible. And because micro makes you think small, and not all services are small. A service, in my mind, every service is an application, and its interface happens to be JSON or XML, but typically JSON these days. And so and there's a high cost to calling a service because you have to, you got network latency with HTTP or queuing or whatever you used to communicate with the service. That was not free, right? And so you can't say that a service is just a trivial method that runs some algorithm, because if that's what you're doing, literally the latency cost to get to the service to run a couple nanoseconds of code, and then milliseconds to get back over the network, that's absurd, right? And yet people try this, and then they wonder why their systems are slow,
right?
But but micro is just bad to start with. But so if we use just the term service in general, I think a service needs to, if you were to build an app that did something for a user, a service should have a similar scope as a targeted unit of business functionality. So you think that I've worked for in a lot of different point of sale systems. And so I think, we've got to be able to add a customer and edit and manage customer data. Well, there's a service, right? And people might say, well, that's a whole bunch of services. But I don't think so. That's a service because that's a unit of business functionality that is cohesive in and of itself, right? And then you probably have a similar thing for product management and inventory management, and then those give you building blocks. So now I can actually build the sales, the process of selling these products, because now I can manage my customers, I can manage my products, I can manage my inventory, and now I can layer on top of that essentially a service that interacts only with these other services.
Yeah, that's a good point. I've heard in conjunction with Azure Functions, people actually suggesting that you can take for instance, add customer and wrap that up in an Azure function. And then, look, we have a microservice for add customer and then a microservice for add product. And it's almost like taking one code path or just two or three, what would be C# methods or classes, and now wrapping them in your DevOps deploy and test and all the strappings that go with versioning and deploying a change to something that has to be run and then monitored to make sure it's up and running, and then all the network latency, versus, okay, let's all pack it together in one big application that's obviously too big. And my brain thinks in continuums. It's like, okay, obviously it's too big. We need to break it up somehow. But putting one function per running process, that's clearly overkill. So where in the process do we stop fixing our problem and then just start creating new ones?
Yeah, and see, I agree with you entirely. I think that there's a happy medium, and we get too hung up on the extremes, right? Oh, it can't be a monolith. That's bad. So we better make it, way fine granular, and then you're going to end up in trouble there too. And we know this. Some of us tried it 20 years ago, and it didn't work then either, right?
That's some of the trappings of SOA. I mean, there were some gyrations in the SOA conversation.
SOA, and even if you go back prior, DCOM and Corba, people tried a lot of these ideas back then too, in the mid '90s. And I mean, just the reality is that the speed of light gets in our way, and unless we can figure out a way to bypass that with tachyon computing, like that's a joke.
I remember in the .com era, where the 3-tier architecture, like you mentioned, the network latency, there was the web, and then it jumped over the network to the COM plus business layer, then it jumped over the network to the database, and that was just 3-tier. And for e-commerce sites that were starting to get lots of traffic, they were just too darn slow. And so then they took all the business logic and says, look, we're just going to run it in the web server because we can't have the second network hop. And for the high traffic systems, for high throughput, you run into that speed barrier fast.
Yeah, absolutely right. And so, if we go back to your example about the add customer and add product, again, I would look at it and say, well, add customer is pretty granular. But then if you step back and think, well, adding a customer, editing a customer, deleting a customer, other operations around maintaining my customer record, all of those share, by definition, they share a lot of business logic and common vision and common functionality. So collectively, in my mind, those probably should be a service. And again, adding, editing, maintaining everything around a product or my product catalog also should probably be a service, right? Because one of the key aspects of a service is that it shares zero code with any other service. And so that to my mind is a pretty inviolate rule. And so if you say, well, so I've got my add customer and then I've got update customer, and these are two different services, they all have the same business rules, but they can't share any code. So that means I'm going to write and maintain that code twice. See, that's the point at which it should be tripping your red flag warnings in your mind and saying, oh, I've got my services are too fine-grained because I can't implement them without duplicating or sharing code. Mm-hmm. Right? Yeah. And that's kind of the way I tend to think about these things.
And since this is a DevOps podcast, we have to ask, how many pipelines do we really need to maintain and operate for this overall system? Can this system, product, inventory, pricing, customer, I mean, let's say we have 6, half a dozen different services or different parts of the application. Okay, that's 6 pipelines. Do we really need a dozen to be that much more granular? Because that's another running versioned application.
And my answer is, yeah, you do. That's something that people. So when I'm talking to especially developer groups about going down a microservice road, one of the things that I'm always crystal clear on is that a prerequisite to doing microservices is that you have to have a mature DevOps pipe, or your not even pipeline. Your organization has to have a mature DevOps worldview. And a lot of people look at me like, well, what does that matter? And I'm like, because right now you're deploying probably one app, right, over and over, because it just does everything. And now you're going to break that one app into a dozen parts, or maybe even 100 parts. I mean, it depends on how granular you let yourself get and how big that system is. And so now your deployment, whatever deployment problems you have today, just multiply them by 10 or by 100.
Yeah.
And, so DevOps is absolutely a prerequisite to doing any sort of microservice deployment, because you are in fact going to be building a lot of smaller apps that are independently deployed and then communicate with each other through messaging. That is the microservice world.
Mm-hmm. Yeah. Well, hey, as we wrap up, we talked about so many great things. What kind of resources would you point our listeners to if they want to learn more about what we've been talking about?
Well, I would, of course, suggest my blog, although I don't blog as much as I used to, but still I try to put some good stuff out there. I I use a tool on Windows 10 called Next Gen Reader. I'm one of the few people that still uses RSS, apparently. And and my feed includes things from the Cloud Native Foundation and from Microsoft, MSDN sources, and some various Java Spring, especially Java Spring sources, because they're all pretty focused on the cloud and container-based world. On the client side, the WebAssembly stuff, that has yet to firm up in a lot of ways, I think. I've been focusing a lot on Blazor, and there's a gitter.im. If you haven't heard of that, it's kind of like Slack, except that each site is attached to a Git repo. And so the Gitter for Blazor is extremely active. Like overwhelmingly. So I kind of poke my nose in there every now and then and see what's going on. So those are some of the sources that I rely on myself.
Okay. So we've got Lhotka.net, and then you also have CSLAnet.com.
Yep, that's true. So for those that want to learn about CSLA and how it lets you create business logic that runs across basically anywhere .net does, obviously would recommend looking at that. Yeah.
All right. Well, I appreciate the time. This was a great conversation, and we covered a lot and a lot of topics for the listeners to sink their teeth into. And so, man, this was fun, Rocky.
It was. Thank you very much.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.